Hello, Code Warrior. Welcome back to Coder's Cafeteria. Today, we have got an exciting topic to discuss. So make sure to hit that subscribe button and ring the notification bell. Yeah, without wasting time, let's jump right in. This is an introduction video for those beginners who are not aware of programming, like how a program is being executed, what happens in the background. If you have a little experience in programming, you can feel free to skip this video. But I suggest you to go through the video. You might find something useful, right? Okay. The computer system has input devices. This feed data, right? And this CPU provides output, right? Via output devices. Via output devices, the CPU provides some output. What is that output? The output is information. The CPU provides information by using the data. What is this information? What is data and what is information? We'll firstly know about data. Data is raw facts or raw values that doesn't make any sense. For example, uh, 21 Rahul. What is this 21 and what is this Rahul? Does that make any sense? Like, what is 21? Is it a rule number, or is it Rahul's age, or is it bank balance of Rahul? What does this 21 specify? And who is this Rahul? Is it a name of a person, or an animal, or a building? What is this Rahul? It doesn't make sense, right? So everyone know that CPU does calculations, and it stores data. We can listen songs. Most of the time, what does the CPU do? It does processing. What CPU does is processing. 80% of what a CPU does is processing. We process data. We take data as input and we process it, and we make information. Okay, what is information? uh, what is information? It is processed data which makes some sense, out of which a user can make decisions. You will understand this statement with an example. I processed the data. I added some extra spices to it. Like, I added a string I am to the value, which is Rahul, and I also added I am, which is a string again, and I added the value, which is data. I concatenated string to the data and made it as an information, which sounds a little informative. Like, I can make decisions out of it. By this information, I can decide whether Rahul can vote in an election. Since he is 21 years old, yes, he can vote in an election. This sounds good. Okay, what does a computer system does most of the time? It takes data, it processes it, and makes it an information. How does it does all these things? How a system does all these things? Uh, we have CPU, right? CPU. What CPU has? CPU has. Have you ever opened and seen the CPU? We find a lot of things in the CPU. We have motherboard, we have storage disk, we have memory, we have processor, we have some circuits, right? Uh, the important things in the CPU are, we have processor, and we have main memory, we have secondary memory. Okay, we have secondary memory. What else we have? Let's talk about this for now. Processor. Processor has registers. You will learn more about these registers later. For now, just remember, processor has registers. It has a control unit. It also has ALU, which is arithmetic logic unit. Control unit is what controls the input and output device, and it controls the instructions. uh, ALU is something which performs operations, mathematical operation or logical operations. Say this is a processor. Simply understand it. Say this is a processor. We have circuits, right? We have transistors, and uh, we have some diodes inside it to form some circuits, right? We have these circuits, like we have some ALU circuit here, and we have some control unit circuit here, and we have some registers here. Then we have main memory, right? Memory. Generally, there are two types of memories. They are primary memory and secondary memory. Okay, we have two types of memories: primary memory, secondary memory. Uh, Primary memory is nothing but RAM. RAM. Secondary memory is ROM. We have RAM and ROM. Let us talk in detail about this. RAM. RAM is costly by uh, what else? RAM is faster. Generally, generally people use 2 GB. 2 GB, not only 2 GB. We can use 1 GB. From 1 GB to 16 GB. You can use any RAM. Okay, volatile. RAM is volatile. Volatile in the sense, okay, when power goes off, the data in the RAM is deleted. You should be aware of it, right? Then we will know about RAM in the sense random, okay, random access memory. I think remove this. Okay, ROM is read-only memory. You will learn more detail in detail about these memories, types of memories in computer organization architecture or analog or digital electronics. Okay, we'll learn more about these types of memories. What is ROM? ROM is non-volatile, which is quite opposite to volatile. Volatile in the sense when it goes power off, the data is deleted, but independent of power, the data is stored in ROM. And ROM is cheap. Okay. General most of people use 250 GB to 2 TB of ROM. Okay, we have cache memory. Cache memory. It is also some type of memory which is more faster. Generally, say if you open Chrome, let's make things interesting, right? Uh, Firstly, what happens is we have secondary memory here, which is ROM itself. What happens is generally, whether it be operating system or whether it be any computer application like say Chrome, Word, Notepad, VS Code, Edge, whatever it might be, whatever application it might be in the system, it is generally stored in secondary memory. All the software of that application is stored in the secondary memory itself. Okay, when you open the application software is loaded onto main memory. Say we have the application size is 2 GB. You see, right? PUBG is 2 GB in Android mobile phone. Likewise, the software files, whatever belonging to the Chrome, whose size is 2 GB. Say, then not this whole now this whole 2 GB is loaded onto the main memory, not the original file, but a copy. Okay, a copy is loaded onto the main memory. Copy, not original, copy. A copy is loaded onto the main memory. Then what happens is this main memory send some parts. Say this is 2 GB data. This 2 GB data is divided, say 10 MB. This 10 MB such parts are divided, and each 10 MB data is sent onto the cache memory. Okay, why data is stored in secondary memory and it is loaded onto the main memory and it is loaded onto the cache memory? Why do we need these many memories? Why can't we I directly connect this secondary memory to the CPU? Isn't it possible? Right? Have you ever got this question in your mind? Why do we need these many types of memories? Why can't we directly connect this secondary memory, which is ROM, directly to the CPU? Why can't we do this? Uh, the problem is the secondary memory is slow in speed. The data exchange rate of secondary memory is slow. Okay, when it comes to main memory, it is faster. Okay, it is faster, which is 4 times faster, into 4 times, into 4 times faster. But still, this speed is not sufficient to give, to feed data to the CPU. So we again use cache memory, okay, which is more faster than main memory. Okay, now from this cache memory, the data is transferred to registers. Okay, registers. Now the data is transferred to registers. Registers are within the CPU itself. These registers are located within the CPU itself. These cache memory is closely connected to the CPU, and these registers are within the CPU itself, as I have shown you here, right? Okay, which are located within the CPU itself. These registers feed data to the ALU and CU. Okay, now this data is fed to the ALU and CU. This is what happens when you open Chrome. The Chrome is generally present in the secondary memory, which is loaded onto the main memory. And here, main memory is nothing but RAM. Okay, don't get confused. This main memory is, this is also called as primary memory. Okay, also called as primary memory. It is also called main memory. It is also called RAM. We have different names here, right? Uh, what happens when you close the Chrome application? What happens is the data is simply deleted. It is deleted on the main memory, cache memory, registers, and everything. It is just deleted, but it is not deleted in the secondary memory. That's why we are sending the copy here, not the original file. We are not moving, we are copying. Okay, uh, what's next? What happens in the ALU and CU is, uh, the instructions are executed. Like, say, we know that Chrome is a computer application, right? Which is a software application, right? In what is a software application mean? We have many number of files. We have many number of files, which are written in some different programming languages. These each file is a program. Okay, each file is a program. This program has multiple lines, which are called instructions. Remember this word. Each program is a collection of instructions. Well, right here. Okay, a program is a collection of instructions. At the beginning, we discussed data is fed to the CPU, and CPU process the data, and it gives information, right? This is what we discussed at the starting, right? Here, the CPU uses these instructions. You might have wondered how a hardware understand these instructions. How does it understand? Say, if we write A plus B, how it understands to add these two values? How does it understand? No, the system doesn't understand A and B, and this is addition. It doesn't understand like, it understands only zeros and ones. Zeros and ones. Okay, it understand only zeros and ones. Say I want to add 2 plus 3. How can you make the system understand 2 and 3 using these zeros and ones? We have techniques. This is binary language. Let's talk about zeros and ones. Why a system understands zeros and ones first? Then we will go about the binary numbers. Generally, a system understands only on and off. When the power is we when we supply power, when we supply power, it understands it as a one. Okay, it is one. When we off the power, it is zero. Whether it has power, whether it doesn't have power, that's all a system understands. We represent this power on and power off as uh, 1 and 0. Now, using this power on and power off, we can also make it understand numbers. When you supply power to the circuit, it is treated as 1, and when you don't supply power to the circuit, it is treated as 0. We use this series of ones and zeros, something like this. We use this series to tell it something. Say 2 is represented as 1 0. Okay, 2 is represented as 1 0. When you send this 1 0 to the system, it understands it as 2. Okay, like you turn the power off initially and then turn the power on next, then it understands it as 2. Okay, likewise you can make it understand 3 using this series of zeros and ones. How do we represent 2? How do we represent 3 or 4? How should we represent these numbers? Actually, each digit in this series is multiplied with uh, 2 power some k. Okay, the k value increases from right to left. Okay, this k value increases from right to left. We multiply each uh, bit. We say this as bit. Each individual element in this series, we say it as a bit. Okay, each bit is multiplied with 2 power k. The k value starts from 0. Okay, say you want to represent 2, right? 0 is multiplied with 0. This I have taken this 0. Okay, this 0 is multiplied with 2 power 0. Okay, then I add this with 1. Okay, 1 into 2 power. Now k value is increased by 1, like this. What will be the result of this? You say it's 0 plus this is 2, which is 2. Okay, this is how we represent a number in binary. Let's take for 3. 3 is represented as 1 1. Okay, 3 is represented as 1 1. Now I take 1 into 2 power 0 plus 1 and 2 power 1. What is the value? 2 plus 1, which is 3. Okay, you might know the mathematics, right? 2 power 0 is 1, not 0. Okay, yeah. Now how a 4 is represented? How 4 is represented? 1 0 0. Okay, here we took 2 and we took 2 bits, but why 3 bits here? This depends on the architecture of the system. The number of bits we take depends on the architecture of the system. You might know that 64-bit architecture, 64-bit operating system, or 64-bit CPU. You also had that 32-bit architecture or 32-bit CPU or 32-bit operating system. You might hear these terms, right? 32 bits mean nothing in the sense uh, the CPU has the CPU read data, right? Okay, the CPU read data, right? The CPU read data with these 32 bits of lines. It has 32 bits of lines to connect. Okay, these are totally 32. In 64-bit architecture, similarly, it has 64 such lines. Okay, 64 such lines. Similarly, when you send 2 2 as a value 2 as a value to this CPU, we send 32 bits to this CPU. Okay, 32 bits to the CPU. The 2 number, which is 10, is represented using 32 bits. Let me show you how it is represented. 0 0 0 0 0 0 0 so on. Say there might be 30 zeros. These will be 30 zeros, and last 2 will be 10. This is how 2 is represented in 32-bit architecture. Okay, likewise for 64-bit architecture, there will be more zeros here. More 32, I think so. More 32 bit, more 32 bit, 0 bits will be there in the left side. Okay, wholly this is 2. Okay, likewise for 4, there will be more zeros in the front. So we can represent any number using this bits. Okay, well, this is good, but still here you might have a question. Then these are positive numbers, right? How about negative numbers? How negative numbers are represented? Actually, what happens is out of those 32 bits series, say we take 2, this first most, this is called most significant bit, this is most significant bit, this is least significant bit. Okay, this most significant bit is represented with 1. If it is 1, the number is negative. Its most significant bit is 0, then it is positive. Okay, if this most significant bit is 1, then it is negative number. If this most significant bit is positive, then it is positive number. This is how data is represented, okay, in a memory. This is how the memory stores a number. Okay, it has many circuits, it has many circuits. They have some transistors here. Okay, each circuit has some transistor here. If there is power in this transistor, it is 1. If there is no power in this transistor, it is 0. Likewise, 1 0 0 1, like this. How this is how this is memory. This memory has many circuits. Okay, this is how a value is stored, the data is stored in a memory. Wow, nice, interesting, right? Similarly, this is how instructions are represented in the binary language. Okay, you should have a doubt here, like uh, when it is power on, it is 1, when it is power off, it is 0. We have multiple zeros, right? Multiple zeros. It's okay if it is 1, the first bit is 1. It's okay if the power is on. uh, it understands that there is something, a series of bits. Okay, the system understands there are series of bits, 1 0 and 1 0 0. Okay, this is how if there is 1 at the starting, it understands it as the series. Okay, what if there is a 0? There is no power, right? uh, and then we have 1. Will the system detect the series started from this one, this 1 bit, or from 0? To address this problem, we have counter. Okay, in the CPU there will be a counter for each 10 milliseconds. uh, there will be there will be something, a wave similar to the alternating current, similar like alternating current. This is a digital wave. This is AC wave, right? Alternating current wave, right? This is alternating current wave, right? This is how current flows, right? This is time. This is time, and this is voltage. This is voltage. Similarly, here there is some time gap. Okay, there is some time gap when we convert this AC to this DC. There is some time gap. Our goal should be to convert this AC to this direct current with some variation in voltage, where the time gap here will be similar to the time gap here. We can also alternate the time gap uh, in this. Okay, this is how this act as a counter. Okay, when the input power, this is a primary input power, ultimate input source. This is the ultimate input, power input to the system. Okay, uh, when there is a positive signal here, and there is a negative signal, uh, negative signal. This is data input. Okay, data input. This is data input, and this is power input. Okay, this is power input. This is power input. When there is a positive stroke, and when there is a negative stroke, it is treated as 0. Okay, this is treated as 0. And for the next positive stroke, if there is a positive stroke of data, this is considered as 1. Okay, this is how a sequence of 1 0, whatever it may be, at the beginning it is 0 or 1. This is how a data is understood by, a sequence of bits is understood by the CPU, and data is represented. Okay, Yeah, that's all for today. Thanks for watching. We put lot of effort in making these videos. Please like, share and subscribe.